Okay, so this is going to be part B of transformations of quadratic functions, because the second part of this goes into what's called vertex form of a quadratic, and that's when you bring kind of all your transformations together. So the vertex form is written right here. F of x equals a times x minus h squared, and then plus k on the outside. So you have your h and your k, and of course your a value, your multiplier, on the outside, and the vertex is h comma k. So if we take a look at the two functions down here, the parent function g of x is in orange. Notice that the vertex is right here at 0, 0. This h value, it looks like a plus 3, but remember it's supposed to be a minus, so it's really technically minus a negative 3, so h is really negative 3. And then the k value here, k value is a minus 4. So what that means is the vertex, or that point right here, moved 3 units left and 4 units down. So 3 units left, and then 1, 2, 3, 4 units down, and this is the new location of the vertex. If you wanted to graph other points, you can still do something very similar. However, you also have this times 2 on the outside. So this is a vertical effect, and this is a vertical effect. Now, which one do you do first when you do your calculations? Well, this is a multiply over here, so you got to do that first. So I'll show you how that actually transforms. So let's say we take this point right here. This point is actually at 2, 4. You can't simply just move this thing 3 units left and 4 units down. Watch what happens when I try to do that. 1, 2, 3 units left. 1, 2, 3, 4 units down. You'll see it doesn't land back on the graph. It's got to land somewhere on this blue graph. Okay, so how do we make that transformation? The reason it worked with the origin is because the origin is at 0, 0, so when I multiply this number by the 2 first, so 0 times 2 is still going to give me 2 or 0, and then I subtract 4 from it, and that causes a vertical shift to the graph. All right, so how do we make this work? So we make this ordered pair a little bit bigger. We put the 2, and we leave some space. We put a comma, and we leave some more space here. Now, the x-coordinate is going to have a shift left of 3, so that's minus 3. So that's like saying take away 3 from the x. So 2 minus 3 is going to give us a negative 1. So what is it we do with the 4? Well, we've got two calculations. We've got a times 2 and a minus 4. So which one do we do first? Well, obviously do times before subtraction. So we're going to take the 2 and times it by the 4. And then minus 4. So this is my a value, and this is my k value right here. And then 2 times 4 is 8, and then 8 minus 4 is 4. So the new transform point is going to be negative 1, negative 4. And let's check to see if that's accurate. So if I go left 1 and up 4, you can see I land back on the graph. So let's see if we can reproduce that with its reflected point. So the reflected point of this one will be this point over here. So let's transform that point. So its ordered pair is, looks like negative 2, 4. So negative 2, comma 4. And it should be reflected or transformed to the reflected point of this one, which is the transform one. So it means it should be over here, and the ordered pair there is negative 5, 4. So let's check and see if that's valid. So remember, the first thing we're going to do is take the x-coordinate and do what the h value says over here, which is minus 3, so negative 2 minus 3. Then we're going to take the y-coordinate, which is a 4, and do what it says over here, which is times 2, then subtract 4. So I'm going to times that by 2, and then I'm going to subtract 4. Move this point out of the way. So the first one is going to be negative 2 minus 3, which is giving us an x-coordinate of negative 5. So we can see this is at negative 5, so the first part checks out. And then the 2 times the 4 is going to give us the 8, and 8 minus 4 is going to give us a positive 4, which is this point right here. And as we go together, we can see it does check out. So it does work correctly, but you got to do it in the proper order of operations. Okay, so now we're going to do multiple transformations of a quadratic. So this is in vertex form here. This is what it would look like if we did it in just pure function form, where the negative 3 would be multiplied on the outside. The negative 1 would still be on the, or the minus 1 would still be on the inside of the parentheses, and of course the minus 2 would be on the outside of the parentheses. So anyway, the transformation, let's go ahead and do those. The vertex is the easiest one, because remember, this is called vertex form. So the vertex is h comma k form. Well, h is this 1 that's right here, and k is that negative 2. So the vertex is going to be located at 1 comma negative 2. Now a lot of you are looking at it going, well, it's -1. That's correct, but the minus is already there, so h was actually positive coming in. So one way to think of it is look at it as the opposite of what you see. So if I see a -1, it's actually a +1. Now the number on the outside is always at face value. So 1, -2 is going to be to the right 1 and down 2, which is this way. Now remember, this a value out in front is a negative, so that would be a reflection. So I'm expecting this graph to go upside down like that. So this is my vertex right here. So everything should be kind of downwards in this direction as I calculate my transformations. Okay, so let's transform this one first. So this one is at 1, 1. And the rules to transformation, the x value is going to be controlled by the h, which is a +1. So it's going to be 1 + 1, comma. And the y coordinate is going to be controlled by the a, which is -3. So a is -3, and the k value is -2. So I'm going to multiply by a and then subtract 2. So -3 times the 1, and then -2 from that. So my transform point is going to be 1 + 1, which is 2. And then -3 times 1 is -3, and then -2 is going to give me a -5. So this ordered pair here should transform into that pair there, which is 2, -5. So to the right 2 and down -5 would be right here. Now since this has an axis of symmetry, which is right here through the vertex, all I got to do is reflect that point over. Now I want to do one more point, make sure it fits on the graph. So let's choose this point right here. And that point is 2, 4. And I'm going to perform the same calculations as above. So I added 1 to the x, so 2 + 1. Then I times the y value by -3, and then subtracted 2. So notice this +1 and +1 are the same. The times -3 are the same, and the -2 are the same. So my new ordered pair would give me a 3. 2 + 1 is 3. And then here I have -3 times 4, which is -12, and -12 -2 is going to give us a -14. So 3, -14 would be my next ordered pair. So 3, -14 would be here. Now remember, my axis of symmetry is supposed to extend down, so my reflection point will be 2 units on the other side, because I'm 2 units away from the axis, so 2 units on the other side. And now I can just go and graph my parabola. It looks something like this. Okay, this next one's going to look difficult on the surface. It says write an equation of a quadratic function. Well, one of the easiest ways to write an equation for a quadratic is in vertex form, especially from a graph. Remember, the vertex of our graph is h, k, and this is our vertex form, so the h and the k value come from the vertex itself. So if we look at our vertex, which is here, the ordered pair there is -3, comma, my arrow's in the way, -3, 5. So my h value is -3, my k value is 5. So if I were to rewrite that formula, I have a times x minus a -3 squared plus 5. And if I simplify that a little bit, a times x plus 3 squared plus 5. So the only thing I'm still missing here is the a value. Well, we can calculate the a value by doing a little substitution. So I can substitute the x and the g of x by using a point from the graph itself. So let's say I choose this point right here, which is at -2, 3. So this is x and this is g of x. Yes, it is the y value, but remember, g of x is the same thing as the output for y. So I'm going to substitute a 3 in for g of x, so put a 3 here, equals, I don't know what the a is, that's what I'm trying to calculate, but the x coordinate is going to be this -2 plus 3 squared plus 5, and all you got to do is solve for a. So if I do what's inside the parentheses first, I get -2 plus 3, which is 1, and then 1 to the second power is just 1. So 1 times a is just going to give me the a. So 3 equals a plus 5. And then subtract 5 from both sides, and a ends up equaling -2. And the negative is expected because this graph is a maximum. It's flipped upside down. So our final equation here is going to be g of x equals, now our a value was -2, times x plus 3 squared. Now I could have put minus a 3 in there, but I left it as plus 3 because it's a little bit neater looking. And then the k value was positive 5, and this is the function that represents the graph that's shown.